Are you looking for a unique DIY project that you could gift your partner or a friend? In this video, I'll show you step by step how to build an LED photo frame that pulses in sync with your heartbeat. The LEDs glow faster or slower depending on your heart rate, creating this beautiful beating heart effect. This project is suitable for beginners and is easily customizable. So let's get started. Let me walk you through how it works. At first glance, it looks like a regular photo frame. But once you flip the switch, the LEDs illuminate the photo and the screen displays a custom message. When you place your finger on the sensor, the frame begins to pick up your heartbeat. Within a few seconds, the LEDs shift into a glowing heart shape that beats in perfect sync with your pulse. Let's take a look at the components you will need for this project. First, you will need a photo frame. I'm using an 8x6 inch frame here, but you can pick any size that you like. Next is the LED matrix. I recommend to use the WS2812B LED matrix, and I have used here the 16x16 pixel version. WS2812B are individually addressable RGB LEDs, which means that you can control these LEDs individually using just the 3 wires. The dimensions of the LED matrix may be bigger than your photo frame, but don't worry, they can be cut to shape. For microcontrollers, I started with an Arduino Nano, but found out that I was running out of memory during runtime. I could have used this Arduino Mega, which is quite bulky, but a much better alternative is this, the ESP32. The ESP32 is compact, has plenty of memory, and is also quite affordable. For reading the heart rate, I used a Max 30102 sensor. These are heart rate sensors and are cheap and easily available. I used an OLED display to display the messages. This one is a 0.96 inch display. I also used a buck converter to drop down the voltage to 5 volts and a battery holder that can house 8 AA batteries. This one comes with its own on-off switch, so I don't have to wire another switch. If you have a 5V power supply or a 5V adapter, you can skip the batteries and the buck converter. However, I would advise against using these 9V alkaline batteries. They quickly run out of capacity as we are powering multiple LEDs at once. And lastly, to put these together, you will need some Wago connectors, a board, and some connecting wires. Now let's move on to the actual build. Choose a photo of your choice for the frame. You should be able to swap it out later. Also pluck out these metallic hooks so they don't get in the way of the electronics. Now take the LED matrix and place it just behind the picture. I also cut this slot on the back cover of the frame to route the wires out. Sandwich the LED matrix between the photo and the back cover of the frame. You can cut out the output set of wires and also the additional power wires as I won't be using them. If the LED matrix is bigger than your frame, you can also cut out few rows to make it fit. The LEDs are numbered in a continuous way from the input to the output. So make sure you cut at the output end of the matrix and never from the input side. I had to cut the last 2 rows of the matrix to make it fit in the frame. Let's start wiring everything together. The battery I used has 8 AA cells and hence gives 12 volts. I'm converting this down to 5 volts using the buck converter. If you already have a 5 volt supply, you can skip this step. Now we connect the 5 volt output to the V-in of the ESP32 or the Arduino if you are using one. Then connect the ground of the supply to the ground of the ESP32. Now connect the 5V and ground to the positive and ground of the LED matrix. Finally, connect the data input of the LED matrix to any digital pin on the ESP32 or Arduino. Here I've used pin 4. Before we add more components, let's understand how to program the LEDs. Now, if you are using ESP32 for the first time, I will be adding a video to help set it up. To work with these WS2812B LEDs, we need to install the FastLED Library. Once this library is installed, we can start writing our code. We need to define the total number of LEDs in the matrix and initialize the LED array. Remember, the LEDs are indexed starting from 0. Let's try turning on the very first LED with the color red. After uploading the code and switching on the power, you should see that first LED light up in red. The FastLED GitHub page has a full list of available colors, and you can even define your own by providing custom RGB values. Now let's try turning on the first 20 LEDs in sequence. We can write a for loop to light up each LED one by one with a short delay in between. On turning the battery on, you can see this animation happening. We can form any pattern we like, such as this heart shape, as long as we know the corresponding LED indices in the matrix. To make this easier, I replicated this matrix numbering on a spreadsheet. Then I simply highlighted the cells that would form the heart shape, yellow for the outer heart shape and green for the inner heart. I then made an array of these numbers in the Arduino program, arranged in an anti-clockwise order, and also provided the total size of this array. Now when I run the for loop, I can see the LEDs tracing out the shape of the heart. In the full code, in addition to the heart patterns, I've also defined arrays for the rainfall pattern that occurs when you first turn on the frame. These are just alternate vertical columns of LED indices. I'm also using few other things to make the effect more appealing. Instead of a single color, I'm using a color palette with a range of colors. I'm using a sine wave function to sync the LEDs with the heart rate. I'm also using the blur and fade effect to smooth out the transitions. I learned about all these effects and more from Scott Marley's playlist on FastLED Basics. If you're getting into LED animations, I highly recommend checking out his videos. Before we move on, let's take a look at the heart rate sensor. I'm using the MAX30102 sensor, which can measure both your heart rate and your blood oxygen levels. I've soldered it onto a small board and added some connecting wires. Here is how we'll hook it up to the ESP32 or Arduino. The sensor needs 3.3 volts to run, so we connect V in to 3.3 volts. Next, connect SCL and SDA. On the ESP32, SCL goes to D22 and SDA goes to D21. For Arduino, this would typically be A5 and A4 pins. And finally connect ground on the sensor to ground on your board. Now let's move on to the code for the heart rate sensor. The first step is to install the library for MAX30102. The SparkFun MAX3010X library is the one we need. Once that's done, go to File, Examples and to the SparkFun library. Open the example 5 heart rate code. This example sketch has everything we need. The code reads the infrared sensor readings from the sensor to detect your heartbeat. It then averages 4 readings before displaying us the BPM or beats per minute. You can upload this code onto your board. Once it's running, just place your finger on the sensor and you should see the BPM readings on the serial monitor. The last component to add onto our frame is the OLED display. As you can see, I have glued this display onto one side of the frame. Here is how the wiring works. The OLED display uses the same SDA and SCL pins. You can connect it to the same pins that we used earlier for the heart rate sensor. However, the OLED needs 5 volts instead of 3.3 volts. Hence the VCC and ground will be connected to the outputs of the buck converter. With that, our display is wired up. Let's set up the code for the display. We will first need to install 2 libraries. The first is the Adafruit GFX library and the Adafruit SSD1306 library. Once these are installed, go to Examples, Adafruit SSD1306 and open the example file 128 by 64 I2C. Remember, we are using the 128 by 64 pixel OLED display. The only change you may have to make here is the screen address variable, depending on your module's I2C address. You can then upload this code onto your board, and you should see a variety of animations running on the screen. But how do you display your own image on the screen? Here I have few image files prepared, but you can choose any suitable image of your choice. Then search for image to CPP and open the GitHub webpage. This tool lets you upload an image and turn it into C++ code that the OLED can display. Set the necessary details such as background color, brightness to improve the resolution, and whether the image should be centered. When the preview looks good, just add a prefix and generate the code for the image. Now we can copy this bitmap array into a sample code. I will leave a link to this code in the description. All we need to do is paste the bitmap array into the sketch and then call it inside the drawBitmap function using the correct array name. Once you upload this code, your image will appear on the OLED display. Now that we have gone through each part individually, it's time to put everything together and look at the full and final code. This final sketch is basically a combination of all the codes we explored earlier. We include all the required libraries and declare all the variables, such as the number of LEDs and the display screen size. We set up arrays of LEDs for the outer heart shape, the inner heart shape, and the vertical columns for the rainfall pattern. I'm also defining color indices here, which will be used to randomize the colors across the different patterns. As I mentioned earlier, we are using color palettes for the LEDs instead of sticking to a single color. Here I have defined two palettes of 16 colors each. We will use this for the heart shapes and the rainfall patterns. Below this section, we have the bitmap arrays for the different heart shapes that appear at different stages of the program. Inside the setup function, I'm assigning random numbers to the color index arrays, so that every time the program starts, the colors look a little different. I'm also initializing the LEDs and the heart rate sensor. Let's look at the loop function now. We calculate the average heart rate just like it was done in the example code. Once that value is ready, the average BPM is displayed on the OLED screen. Below this, in the run heart sine beat palette function, the BPM value from the sensor is used to control the brightness of the LEDs. First the outer heart shape beats and then the inner heart shape. Notice that in the inner heart shape I have added a phase offset, so it beats out of sync with the outer heart. As mentioned earlier, we are using the blur effect to spread out the light to neighboring LEDs and make the effect more appealing. Big shout out once again to Scott Marley's FastLED videos, which introduced me to many of these techniques. Finally, for the vertical rainfall pattern, we apply the same principles as the heart shape animation, except this time we don't use the BPM to control the brightness. And now that everything is in place, upload the final code and see the photo frame come alive. For the arrangement of parts, I have placed most of the components behind the frame. This breakout board made wiring much easier without the need for soldering. I have also glued on these wooden bits to help the frame stand upright. That's it for this build. I hope you enjoyed it. I would love to hear from you. Please let me know in the comments how you get on and if you tried any fun variation of this project. Thanks for watching, and I'll see you again with another DIY project.